All right, so you want to take this picture and use it to fill in the table you have here on your paper. And I'm going to point out some things while you do that. You may or may not have chosen to see the optional video on the derivation of these formulas for the derivatives of the inverse trigonometric functions. But you do need to know all 6 of them because they show up on the AP test. So let me just point out to you as you memorize them, because you will memorize them. This chart is organized by cofunctions. So sine and cosine are cofunctions, tangent and cotangent, secant and cosecant. And if you look at the derivatives for cofunctions, notice the only difference between these 2 derivatives is the negative sign in the cofunction. These derivatives are the same except for the negative in the cofunction. These derivatives are the same except for the negative in the cofunction. And now let's talk about the fact that these formulas have u's in them. If I had shown you this list before you had learned about the chain rule, I would have told you something like this. The derivative with respect to x of inverse sine of x is 1 over square root of 1 minus x squared, and we would have been done. But now we know that we can take derivatives of more complicated functions if we apply the chain rule. So what's really printed here for all 6 functions, 6 inverse trig functions, but I'll just explain it in terms of the inverse sine function. Now instead of just telling you how to take the derivative of inverse sine of x, here's the derivative of the inverse sine of anything. So you can take the derivative of the inverse sine of any function. So sometimes we've called that the blob, sometimes we've called it the inside, sometimes I stick a yellow star over it. And that's going to be, you're going to use this formula, it's going to be 1 over the square root of 1 minus this thing squared times the derivative of that inside with respect to x. So now that you have those 6 functions written in on your paper, we're going to do some practice problems with them. Okay. So here, this is also page 175 in your book. If I want to take the derivative with respect to x of inverse sine of x squared, well, I have to ask myself, what's standing in for u? What's the thing that's getting inverse signed? You can write yourself a note, or you don't have to. At the beginning, you might like to write it down and then find that later you can do it without writing this down. I think the thing standing in for u is x squared. So if I'm going to use the formula that you wrote in at the top of your page, I'm going to need du dx. So the derivative of u with respect to x is 2x. So the derivative with respect to x of inverse sine of x squared is going to be 1 over the square root of 1 minus u squared, but u is x squared, times du dx, 2x. This is a great answer. You can use it on the free response section. You could give this on my test and we get full credit. Notice if you're going to take the multiple choice section, you would need to simplify this, or at least be able to pick it out of a bunch of multiple choice options. Typically that 2x would come to the top, and then the square root of 1 minus x to the 4th. It's a 4th up there. Final answer. All right, try this guy. 2 more to do. So, okay, so now I'm going to combine everything I know about position, velocity, acceleration with my new functions. I have a particle moving along the x-axis, and here's its position function, inverse tangent of square root of t. What is the velocity when time equals 16? Well, velocity is the derivative of position. So I'm going to find v of t, which is going to be the same thing as x prime of t. And that's going to be, I notice that I'm going to have the inverse tangent of something, but it's not a plain old boring t. So I'm going to write myself a note that in this case, u equals the square root of t. So du dt is going to be 1 over 2 square root of t. I hope you got that one memorized by now. So the derivative of inverse tangent is 1 over 1 plus, in this case, u squared, but my u is square root of t. I'm going to multiply by du dt. That's going to be 1 over 2 square root of t. That's a great answer on the free response section, or my test. You might find this answer choice if I was going to guess. It would be how it would be written on a multiple choice test. Instead of, for example, trying to distribute this 2 square root of t with the 1 plus t. But that would be how you... So either one of these answers gets full credit on my test. Okay, and then I got one more here. So do you really remember the inverse secant, the derivative of inverse secant off the top of your head? Okay, so let's make some room here. Before I get started, I'm going to notice that u, in this case, is 5x to the 4th, and du dx is the 4 multiplies the 5 to make 20x to the cube, x to the 3rd. All right, so the derivative of the inverse secant is 1 over, it's going to be the square root of u times the square root of u squared minus 1. Oops, except I don't want to write u squared, I want to write u squared minus 1. I'm going to multiply by du dx. So what is u? It's 5x to the 4th, 5x to the 4th. That's going to be multiplied by 20x cubed. If I was going to guess, I hope you would leave this answer in the free response section. It's fine. If I was going to guess what the most common incorrect answer given is, it would be people trying to take 5x to the 4th and squaring it, but accidentally only squaring the x to the 4th. For example, not remembering that 5x to the 4th all goes in parentheses and all gets squared. Oops. So you could write this final answer. The 20x cubed might come up front. 20x cubed. This is the absolute value of 5x to the 4th. Square root of 25x to the 8th minus 1. That's the answer I would expect on a multiple choice test. Feel free to leave this answer or this answer on the free response. So now you have some practice using the derivatives of the inverse trig functions.